So now we come to graphing quadratic equations in our normal quadratic form, the ax squared plus bx plus c. There's some similarities to standard form, but there's some very big differences, and there's a different strategy and technique that you need to use. I'm going to expect you in the end to be able to look at both of them and determine what technique you need to use to get to your answer. So let's get started. The steps to graphing in the form f of x equals ax squared plus bx plus c. First thing we're going to do is determine, does this open up or down? Then we're going to determine what the axis of symmetry is. That's that vertical line that cuts the parabola in half and acts as a reflection line. And that formula for the axis of symmetry, because it's a vertical line, it's going to be x equals, and the value of x is going to be minus b over 2a. We're going to work in class on developing that formula, but for now I just want you to be able to work with the formula. So then the vertex, if the x value is negative b over 2a, we need to plug in that value and solve for f of x, or solve for y. So it's going to be negative b over 2a, f of negative b over 2a. Determine what x is, plug in x to solve for y. Fancy way of saying it. Then the x-intercepts, we're going to take ax squared plus bx plus c equals 0, and we're going to find the two roots of that. And finally, the y-intercept, this is easy when it comes to this form. The value of c, the value of that last letter, that is the y-intercept. Then you want to plot those 5 points, the vertex, the two x-intercepts, the y-intercept, and then the reflection of the y-intercept. Okay, so let's get an example. Example number 3, graph negative x squared minus 2x plus 1. So the first thing we want to do, we know this opens down, and we know it opens down because we have a negative in front of our x squared term. All right, the next thing we know is the value of the value of x for the horizontal line that goes through the center of the parabola, which is the axis of symmetry, is identified by negative b over 2a, which in this case is going to be negative 2 over 2 times negative 1, which is negative 1. So it's going to go a vertical line through negative 1 on the x-axis. So we're going to put that in, and it's our little dotted line. And by the way, it's a dotted line because it's not part of the graph. It just helps you identify the components of the graph. Okay, now we're going to take that negative 1 and plug it back into our formula to find when x is negative 1, what's y. So we have this negative 1 squared minus 2 times minus 1 plus 1 gives us 2. So that means that our vertex is at minus 1, 2. So now we're going to plot that right there. The next thing we want to know is what will our x-intercepts be? Well, we know this opens down and the vertex is above the x-axis, so we know we're going to have two real roots. So x squared plus 2x minus 1 equals 0. We get x equals, we have to do this with the quadratic formula, so x equals minus 2.4 and x equals 0.4. So we're going to eyeball that. Remember, we're only sketching this. So there's our two numbers. Now, the y-intercept is 1 because that's what the value of c is. So we've kind of jumped ahead here. I forgot to put a stop in. Sorry about that. Jumped ahead and put that in on the y-axis. And we know now that that is 1 unit away from the axis of symmetry. So we go 1 unit over the other side and we have that point. Now we have our 5 points and we can draw our graph. And we're sketching. We're just sketching. Remember, this is not a V. This has a curve to it. All right, so let's ask this question. What's the domain and the range of this function? Well, the domain is going to be all real numbers, regardless. But the range never gets never gets above 2 on the y-axis. So one way we could write this would be the range is all y such as y is less than or equal to 2. There's other ways of doing it. We'll do it another way in the next example. So go ahead and do your checkpoint number 3. Okay, example number 4. we have minus 3x squared plus 6x minus 15. We're not going to graph this. We're going to ask for some information. You can do a little sketch graph if you want, just to visualize, but we want to ask these three questions. Does f of x have a minimum or a maximum? We want to find the minimum or the maximum, and then we want to identify the domain and range of this function. So for our first question, it opens down, and we know it opens down because we have a negative 3 in front of our x squared. So keep that in mind. So the vertex, if it opens down, the vertex is a maximum, because the vertex will be the highest point on the graph. Find the minimum. Well, minimum value, we have to find our x first, which is minus b over 2a. And we plug in our values, we get that equals 1. So x equals 1. Now, that doesn't tell what the minimum or maximum, it only tells the x value. We need the y value to know what the minimum or the maximum is. And, by the way, we know that this is going to be a maximum. So we plug in, and we get this negative 3 square root of 1 squared plus 6 times 1 minus 13, which is minus 10. So minus 10, and I'm going to kind of make a point of this here, minus 10 is our maximum, because the maximum is always going to be the y value. All right, so that's our maximum value of y. So that means we can write our domain is going to be all real numbers. Now I'm going to write this in interval notation, okay? And so our range is going to be from negative infinity to negative 10 included. So I have a parenthesis before the negative infinity, and I have a bracket by the negative 10. So I want you to do the checkpoint number 4. You're going to follow these same ABC rules. You're not going to be graphing it per se, but you're going to be answering those 3 questions. And there's the baby. I will see you in class. Good job, everybody.